I'm Andrea, and I'm from Polytechnic University of Milan, and I'm a team member of Milanese PRC, which is the Polymer part course, the Formula student team of Polytechnic University of Milan. The Formula student team of Polytechnic University of Milan. We are a project, and we are the racing department of Polytechnic University of Milan, and in our team we are more than 1,000 students, from the first year of bachelor to the last year of master. Our goal is to design and to produce a racing car prototype, as you can see here in the picture, which has the shape of a Formula car. After the car is ready, we compete all around Europe in the Formula Students Championship, which involves university from all around the world. United States, Australia, and also India, China, from all the countries in the world. Thanks to the results we obtained in 2019, which was our last year we competed in the combustion category, we reached the first position in the Italian ranking and the number 4 in the worldwide combustion ranking. As you can see here, these are some, not all, the races which are organized all around the world, and as you can see, the races are from America to Asia, in every country, more or less. You might not know, but the Formula SAE is the third prototype championship in the world, after Formula 1, which is obviously the top, and the WEC, the World Endurance Championship. Because all the other categories are not prototypes, for example, but they are cars which everybody can buy, we can say. And so Formula Student is the third championship all around the world. Our races are divided in two main categories. The dynamic events, which are the most exciting, we can say, and the static events, which are more economic kind of competition and something like that. The dynamic events are acceleration, which is 75 meters straight, and you must complete these meters in less time as possible. The skid pad, which is a track made, it's a 8 shape, and you do 2 turns in two turns left and 2 turns right. The autocross event, which is a sort of qualification for the endurance event, which is autocross is composed by one lap at the top speed possible in the track, and the endurance event, which is endurance, so more or less 20-25 kilometers, about 22 laps of the race with driver change, and it's used to test the reliability of the car. Our history in brief, we started in 2004. At the beginning, the project was not open to everybody, but there were only 10 PhD students. But soon the project opened to everybody, and nowadays PhD students cannot take part in the project, but it's only for bachelor students and master students. Here we have the timeline with the cars we produce and we design every year, and since 2004, 2019 was the last combustion car we realized in our team. After the DP11, we switched to the electric category. Our first electric car is DP12, but the last and so all the project is shifted 1 year after. So this year we are producing our first electric car. Here is a brief recap of our 2019 season, and these results allowed us to become the first Italian team and the number 4 in the world. In 2020, obviously the races were not organized, but there was a sort of online racing with a race of champions, which was the endurance made by the simulators, and the static events, which were because in distance they could be taken. And we gained these results. We won the business plan presentation, we won the concept design challenge, and we were number 4 in the design event, and but this year we will see our car hopefully racing in the design. This is a brief explanation of how is our team structured, and there is a team leader, 2 technical directors, one for the mechanical systems and one for the electrical system, and there is a sporting director. And here on the bottom you can see all the departments in which our team is divided. Chassis, driver interfaces, suspension and drivetrain, vehicle dynamics, and every department has a particular system on the car. We can see. Our working methodology is theoretical because we have not infinite resources, and obviously we are engineers and we set the goals and set the parameters of the performance we want to improve. We make theoretical studies. After we make same analysis for every kind of quantitative models, and we make tests. When we have reached when we think we reached our goal, we go on with manufacturing and assembly. And once the car is ready, we start doing tests in the truck to make sure our studies were okay for the performance. We make our monocoque completely in carbon fiber, and the weight is under 20 kilos. Last year was 19 kilos. It's completely made in carbon fiber with it's completely made of carbon fiber. As at the same way, we can say, we realized the carbon fiber were rims, and they are 100% carbon fiber. We also use innovation in technology and materials. We use 3D printing, metallic 3D printing, which allows to create components like these, which are safe, which can support the stresses, but which are optimized in the shape and in the dimensions. Our tires are realized with Pirelli, and we have a sort of program with them. We work together with Pirelli and we make tests for them, and the tires are specific for Formula students. We are other Italian teams using these tires, obviously not only Polytechnic University of Milan, but they are designed for Formula students. This is a render of our new car. which is going to be ready in some weeks, and it's called DP12E. This is the first electric car we are going to produce. The powertrain obviously is electric, and we chose to mount 4 motors inside each wheel. This was mainly because in this way we're able to reduce the weight, and we have the freedom, the total freedom from a dynamic point of view, because every tire is independent, and it can be controlled not connected to the other. The maximum power is 80 kilowatts, and this is the maximum allowed by the rules. It's not possible to make a more powerful car, because the maximum is 80 kilowatts. And as I said, the 4 motors are inside the tires. The accumulator is a Sony PT-C06 lithium cells based, and it has 30 minutes of autonomy. It's the time needed to complete an endurance racing. It's important to say that we have the regenerative braking. More than 90% of the brake power is given by the regenerative system. And this particular system changes the battery. It's not light, it weighs 45 kilos, and this is why usually the electric cars are, the weight is higher compared to the combustion car. Our new car, I think, is going to be 210 kilos, while the DP11, the last combustion car, was 150, more or less. And that's in particular because that's the way, the maximum. We also design and implement a torque vectoring system, which allows to control each wheel in independent way. The code is entirely written by us and our team, by the students, and also the PCBs are designed by the students, the team members of the team. Obviously, we are not able to produce the PCBs, but we work with sponsors, but they are designed completely by us. And the torque vectoring is important because it allows to have a boost on performance, because you can control every wheel independently. This was the Formula student team of Polytechnic University of Milan, and we hope to do well also in this new category, in this new experience.
Thank you very much, Andrea. We concluded the presentation of our on-the-spot project.